Hello everybody, welcome to the channel. If you are new here, my name is Ken and I'm a freestyle drone pilot. If you are a returning viewer or subscriber, thank you very much for your support. Thank you all for being here today. Today we're going to be talking about motors. We're going to be talking about how to maintain your motors and replace the bearings when they wear out. There's a common misconception that when motors start running rough, they need to be replaced. 9 times out of 10, that is not the case. It is the bearings that just need to be replaced. If the motor bell and the shaft are okay and straight, replacing the bearings will return your motor to an almost new condition. So today we're going to be taking this apart, cleaning it out, replacing the bearings, and I'm going to show you how to do all that here. So without further ado, let's get to the bench and rip this motor apart. So we have some tools over here. I have my trusty driver. This particular motor has a screw. There are some motors that have a clip. You can remove the clip quite easily with a pair of screwdrivers, or if you have the clip removal tool. In this case, it's got a screw, so I have the appropriate driver here. It's a very good quality driver that fits very snug into the screw. That is very important so you don't strip the screw head out. Also have a toothbrush, some isopropyl alcohol for cleaning, a hemostat just in case. I have an M4 screw and my bearings, of course, and some Loctite. The Loctite is very important because that is going to keep your screw in place, and I'll explain why when I'm doing this, okay? Yeah, let's just rip it apart. And normally these screws are Loctite in, of course, so they're stuck. What I usually do to get them loose is I use my soldering iron on maximum heat. I just pop it into the screw. I leave it there for a minute or so until the heat dissipates through the screw and sort of melts the Loctite. That will make it much easier to remove. This particular screw is loose. I don't know why. That may have contributed to the early demise of these bearings. So luckily it didn't come out, but it's fairly easy to remove. So what I'm going to do is I'm just going to push it in there, make sure it's nice and snug and goes all the way to the bottom of the screw head. And as you can see, the driver takes a bit of force to fall out. So let's remove the screw. Underneath the screw there is normally a copper washer or brass washer. Be sure not to lose that if it is present. It is present in this one. Sometimes it'll take a while for it to fall out. There you go. There's a little brass washer. These brass washers are important. Sometimes they're on the outside. Most of the times there'll be one on the outside and also one on the inside of the motor, you know, keeping a space between the motor shaft and the windings, and that will align the magnets up with the coils properly. So if you lose that inner washer is present and you lose it, you might misalign the motor and cause it to skip and cause some issues there. Sometimes it's very hard to remove the actual motor from the shaft because when you put the screw in, the end of the shaft might fray over just a little bit. Since they're very tight tolerances, it might cause the shaft to bind on the inner race of the bearing, so you might not be able to properly pull it out. What I like to do is pop a little screw in, or if this is still on the frame, it'll make it easier to remove. I'll pop a screw in there, use a pair of pliers or the hemostat to grab onto that screw and pull. The magnets will try to keep it in place. I'm holding the wires here, but try not to make too much force on the wires. Make force on the screw and out pops the bell. This one is pretty easy. I have replaced these bearings once before. These motors are 2 years old. Yeah, as you can see, there's a bit of rust in there, so we're going to clean all that off. There's a lot of debris in the motor area, and let us see if we have the inner washer. This motor does not have an inner washer, which means it didn't need to be aligned on the inside. So all the alignment was done. without the washer being needed. Some motors will have it, some don't. Alright, so very tight tolerances, as I say. These bearings are pretty much stuck in there. Most times they will be very, very stuck, and a lot of times you'll have debris from, you know, months and months of use. What I like to do is just grab my driver and swirl it around the inside there so that it cleans the outer race area, so the bearing will slide out better. On this side there's not really much to clean up, so I'll use this toothbrush for that. Now I'm a bit of a brute, so I'm not going to be too careful trying, you know, when I'm removing the old bearings, they're destroyed and they're going to go straight into the bin. But I will take more care when putting the new bearings in, so that I don't put any undue forces and destroy the bearings before they're actually used. So once everything's cleaned around the area, you can then think about removing the bearings. Now the tight tolerances on this will make that a fairly interesting deal sometimes. So what I like to do in this case, use an M4 hex screw, and that goes in there almost pretty snug as well. There's a little bit of play, but I'm going to use that to my advantage. So what I'm going to do is I'm going to leverage the actual threads of the screw to create force inside the bearing area, in the bearing race, so it catches on to the inner bearing race and allows me to pop the bearing out. So what I'll do is I'll put it in just so it goes past, more or less past the first bearing. I'll push to the side and try and start pulling. This might take a while. It might not actually work on one side. If it doesn't, try the other until you can get it out. Oh darn, this is tight. Sometimes it works, sometimes it doesn't. I'm going to use my hemostats so I don't destroy my fingers. Now this is very hard on this one. Wow, it's pretty stuck in there. That is not going anywhere. That is not going anywhere at all. So in this case it is completely stuck. I'm going to use, don't do this, use something else. I don't mind. I'll probably get away with it. But if that doesn't work, you pop your screwdriver in at an angle. As you can see, there's enough space there for this bearing to pop out at the bottom. Put your screwdriver in at an angle so that you hit the lower bearing race. There is like a little bit of an aluminium detent in there between the two bearings that hold them in position. But when you put your screwdriver in like this, you're definitely hitting the inner race of the lower bearing. And just press down on it, give it a couple of taps, and it has come out. So it was really stuck on this one. Now I can use my technique again, and out comes the bearing. So there you go, one dead bearing. Set that aside, don't mix it up with your new bearings. That would be horrendous. And okay, now we can just pop the screw in on the other end and, you know, give it a couple of taps. Until it starts coming loose. That was really stuck. There you go. Pretty stuck that one was. And out come the bearings. Wow. I think that's the hardest bearing removal I've had so far. There you go. So those two bearings are shot. Now we have a coil with no bearings. Now we start the cleanup process. So I'm going to use a little bit of alcohol. Yeah. And I'm just going to brush it over the windings to remove any of the dry dust and dirt and grime that has sit in there over the months of crashing. Just clean that up. put this paper over here just to absorb any drips. Clean it really well. It's almost brand new. Let's dry it up. If you're sensitive to this alcohol, use gloves. It will dry your skin out. It removes the oils from your skin, as you can see. But I'm not going to worry about that now. Too late. Too late. Too late for that. Same thing for the bell. This bell's pretty cool, pretty good. It's a bit rusty on the outside where the branding was engraved, but it's still in very good condition and straight. That is very important. The shaft is straight. That's what she said last night. Let's give it a bit of a scrub. If you're selling your quad off, if you're selling your quad on to someone else and you're doing this, it is always a good idea to clean your quads. Just today I saw a listing on Facebook, a quad for sale, a fairly old quad for sale for £125, and it looked like it had taken a bath in a giant cow pile. I don't know how somebody can list a quad so dirty and expect somebody to pay, in this case, a pretty high sum of money for an absolutely filthy quad. You can see that this motor has taken a bit of a hit, but it has not affected the bell in any way, shape or form. Just dry out the alcohol. Inspect the magnet area for any damage, any loose magnets. If there are loose magnets, you can glue them back in with a bit of cyano glue. And if there's any like caked mud, try to remove the caked mud, but try not to remove the balancing compound that they will have put in the motor to keep it balanced. I don't know if you can see, but in there is an area where the gap has been between the magnets and the top of the bell has been filled with some compound along that edge to actually balance the motor bell. So it's important to make sure that you don't remove any of that. Normally that compound is blue. On most motors I have seen, that compound is blue. Alright, so once your bell is clean, you can then start to think about the reassembly process. Now, as you can see, the inner portion of this motor housing, there's the aluminium detent I was talking about earlier. That's where the bearing will sit against. So the outer race of the bearing will sit against that aluminium detent on either side. What that means is there will be a 2 or 3 millimeter gap between the two bearings in there, and the inner race will be free to move inwards if you put too much pressure on it. So the top of the bell, the top of the shaft will press against one part of the inner race, and the screw will press against the other part of the inner race, and that will create a force in there. Since there's that gap, if you tighten the motor too much, tighten the shaft too much, it will actually put too much force on the inner race and cause premature wear on your bearings, and that will start to cause a failure. So when you put it together, you just got to be careful not to over tighten that nut, and that is why Loctite is so important. The Loctite will guarantee that the screw will stay in place because it's not completely tight. You know, there's not a lot of torque on the screw keeping it in place, so the Loctite is essential there. So let's pop the bearings in. Do this by hand. There's no need to use any mechanical procedure. As long as the bearing goes in straight, it should slide in pretty effortlessly, like so. If you put it in sort of lopsided, it will definitely not go in there, so it's important to get it straight before you put pressure on, so that it will stay there. Now for the bottom bearing, what I like to do is I like to use another bearing and carefully align it on top so that the both outer races are on top of each other, and press it in like so. In this case I need to press it in a little bit further because it is super tight, so I'm going to use the back of my screwdriver, which is plastic, and I'm going to press down on it. So, oh dear, oh there you go, and that is now fully popped into place on the bottom. I'm going to do the same thing for the top because it's like 0.5 millimeter still off the top there. There you go. It is really important not to put any pressure on the inner race. That will cause premature damage, like I mentioned earlier. So now the bearings are popped in, they're pretty tight and pretty snug. We can now pop our bell back on, and that you just align that up and let it go. Boom, it's back in there. We have a silent motor. Absolutely fantastic. Okay, now this is another important bit. This little washer needs to sit very square, very straight on that shaft. It is, as you can see, the inner diameter of that fits the outer diameter of the shaft, and once you tighten the screw in, that will cause the two bearings to tighten up a little bit and remove all the slack between the thingies. So I like to put it on, align it up. I'm gonna have to do that again because I need to grab my screw, pop it on my driver, get the Loctite, put a copious amount of Loctite on there. I definitely don't want this to come off, so I will use more Loctite than needed. And I have to line the washer again. And I'll line it in a minute again, just to make sure it is in place. And I'm just tightening it. Few times. Give it a couple of tugs. If you want, you can put the screw back on and just give it a couple of tugs. See if there's any vertical play. There is none. See if there's any horizontal play by twisting it side like that. There is no play at all. So that, it tells me that that screw is just about as tight as it needs to be. That is too tight now. I can feel the bearings. There you go. That is the motor bearings replaced, and the motor returned to almost new condition. Cosmetically it looks ugly and rusty, but functionally that is 100%, and it will now live for another year. There is a common misconception that another misconception is that you need to lubricate your bearings from time to time. Now, these are sealed bearings. They are pre-lubricated from the factory with very specific grease. And once that grease wears off, theoretically that is the end of the life of the bearing. By lubricating your motors with machine oil or gun oil or whatever other lubricant you choose, what you are essentially doing is flushing out the factory grease, which will lead to a premature wear of the bearing. So you might think you're prolonging your bearings, and if you lubricate them once, you pretty much have to start lubricating them before every flight, and as much as you can, because once you flush the factory lube out, the bearing is reliant on the lubrication that you've put in. And since you're using a liquid lubricant, that lubricant with the speed at which these bearings run will just fling out and cause microparticles to actually adhere to that lubricant, potentially ingress through the seal and damage your motor even more, your motor bearing even more. So the factory lubricant is there. It's good enough for a specific amount of time, which every manufacturer of bearing will have an MTBF value for their bearings. Once that is done, the recommendation is to replace the bearing. You may get away with prolonging it a little bit more and allowing you to, fly for the rest of the day or whatever. But the truth of the matter is, a bearing that is loose will deteriorate very, very quickly. Those vibrations that are induced by that bad bearing in your motor will transfer directly into your flight controller's gyro and cause your quad to fly, perhaps erratically. So motor maintenance is essential if you want a precision flying machine. You don't have to replace the entire motor, you just need to replace the bearings if everything else is physically functional, and you save some money. Each set of bearings will cost you about £2.50 and 10 minutes of time, as you can see here. So I hope this video is useful for you. If you like it, leave a comment downstairs. If there's any issues with the video, leave a comment downstairs. And you're welcome to click the little subscribe button, click the bell, and support the channel. Thank you very much for watching, and I will see you next time.